Hello, everybody. Welcome back. We're going to do now example 18.6, and this is applying the half-angle formulas. And what you're going to see is the half-angle formulas are similar to the angle addition-subtraction formulas. In certain ways, they're simpler, but there's an added complication, and that has to do with the plus-minus. We'll get to that. Okay, so here are the formulas, double and half angles. I'm presenting all of them here on screen, although this example is going to use just the first ones, which are the half-angle identities. So if alpha is an angle, then sine of alpha over 2 is equal to, well, the idea is that we should be able to compute this sine of alpha over 2 using only information about alpha. So in particular, using the sine, cosine, and tangent of alpha, you can see it's plus or minus radical 1 minus cosine alpha over 2. The only thing that we need is the cosine of alpha, and then to do some calculation, and that will give us the sine of an angle alpha over 2. So when you cut an angle in half and you want to find the sine of the resulting angle, this is going to tell you how to do it. Something to note is that plus minus there, this plus minus, and this plus minus is determined by quadrant. So when you come to the end of one of these calculations, you're going to end up with an answer that has a plus minus something, and your answer is just going to be one of those, either plus or minus, and you're going to figure that out by looking at this angle alpha over 2, figuring out which quadrant it's in, and then using the quadrant to determine whether it should be positive or negative. Okay, so that's the strategy. Let me get rid of my notes here. Okay, let's go. And the double angle formulas, we'll talk about those for the next example. All right, we'll coming back and referring to these as needed, but for now, let's look at example 18.6. Find the trig functions using the half-angle formulas, and the first one is let me change my color. This one is sine of pi over 8. Now, something divided by 8, the key idea here is to think of this as it's something that's more familiar, pi over 4 divided by 2. Remember, when you take pi over 4, you divide it by 2. We take the guy on the bottom, we bring it up to the top, and we flip it, making it 1/2 times pi over 4. So this is pi over 4 times 1/2 is pi over 8. You can see that pi over 8 really is equal to pi over 4 divided by 2. And that means that we're going to be using the half-angle identity for sine. So let's go and grab that. Here it is. Okay. I'll just stick that off to the side where we can refer to it. And sine of pi over 8, we're going to just rewrite that as sine pi over 4 over 2. So when you look at the formula, the alpha over 2 is the alpha is pi over 4. And when we plug in for alpha here, the alpha we're going to plug in is pi over 4. Okay. Let's go ahead and do it. That whole thing, it's equal to, well, plus or minus radical, and then we have 1 minus cosine pi over 4 divided by 2. Okay. Now, for this, we're going to need to know cosine of pi over 4. That's one of the ones I know. Pi over 4, that's 45 degrees. That's the one where cosine and sine are the same, and they're both equal to radical 2 over 2. So cosine pi over 4, that one is radical 2 over 2. Let's go ahead and plug that in. So this is plus or minus radical of, you have to keep track of all your radicals and fractions, 1 minus radical 2 over 2 divided by 2. Okay, so that's just plugging in, replacing cosine pi over 4 with what is equal to radical 2 over 2. Now we have to simplify this thing. It's a little annoying because there's a big fraction, and on top of the big fraction there's a little fraction. Here's what we're going to do. We're going to take this 2 on the bottom, we're going to bring it up to the top and flip it into a fraction 1/2, and we're going to multiply it by everything on the top here. Let's do that. We have a plus or minus 1 minus radical 2 over 2. That's the top. And just to make it clear what we're doing, we're taking this 2, we're moving it up. Oops. Taking this 2, we're moving it up, and we're multiplying by 1/2. And when we do that, we need to put the top in parentheses. So that's what we're going to end up with here. This thing is times 1/2. And when we multiply that times 1/2, we multiply through the parentheses, which means we multiply each part by 1/2. So we have plus or minus radical, and multiplying through we get 1/2 minus 1/2 times radical 2 over 2. We're going to multiply the numerators 1 times radical 2 together, and that's the radical 2 on top, and then 2 times 2 is 4 on the bottom. So this is 1/2 minus radical 2 over 4. All right, that's equal to plus or minus radical. Well, let's try to simplify this by adding these two together. To add them together, we need a common denominator. That common denominator is going to be 4. So to get a 4 there, we're going to take the first fraction and multiply by 2 on the top and bottom. And then we get 2 over 4 minus radical 2 over 4. Keep in mind, there are 2 radicals running around in this equation. One big one over almost the whole thing, and then one little one on top of that fraction inside. So this is plus or minus radical 2 minus radical 2 over 4, adding them together into the same fraction. Now, there's one more thing we can do here, which is we have a radical of a fraction, and we can split that up into the radical of the top over the radical of the bottom. So this is plus or minus radical 2 minus radical 2 over radical 4. And the nice thing about that is we can simplify the bottom. Radical 4 is just equal to 2. So this is plus or minus, let's see, radical 2 minus radical 2, whole thing divided by 2. Radical 4 is 2. Okay. So this is our answer, except for the following. We're not going to simplify it any more than that. I know it looks strange having a radical buried inside another radical. There's no simple way that we can make that any simpler than it is now. And so what we're going to do is all we have to sort out is whether this is a positive or a negative. And let's just remember what we're calculating. We're calculating sine of pi over 8. So far what we've found is sine of pi over 8 is equal to plus or minus radical 2 minus radical 2 over 2. And our question is whether it should be positive or negative. Now let's think about this angle pi over 8. Remember, the sign, whether it's positive or negative, is going to depend on the quadrant. If you remember, this angle is 0, and then as we go around, 90 degrees is pi over 2, 180 degrees is pi, 270 degrees is 3 pi over 2, and then all the way back to 2 pi is the same as 0. And the angle pi over 8, it's between 0 and pi over 2. Because forget the pi for just a second. 1/8 is between 0 and 1/2. So it's somewhere in here. That means this thing is in quadrant 1. And in quadrant 1, both cosine and sine are positive. And because of that, so quadrant 1, sine is positive. And because of that, we are going to choose the positive one here. So let's just give our final answer. This is sine of pi over 8 is equal to positive radical 2 minus radical 2, whole thing over 2. Final answer. Okay, so that's how you can see how we can use the half-angle identities to find the sine of more complicated pi over 8. That was not one of our simple angles that we should know the sines and cosines and tangents of, but nonetheless we can find it using this formula. Let's go ahead and take a look at this example, 18.6, part B. So part B says cosine of 9 pi over 8. Let's go ahead and do it. Okay. Well, since this is the half-angle identities problem, you can bet that we're going to be using a half-angle identity, which means that we need to convert this 9 pi over 8 into something of the form something over 2. And the way that it will work is 9 pi over 8 is equal to 9 pi over 4 over 2. Now, the question is, do we know the sine, cosine, or tangent for 9 pi over 4? Let's see if we can figure out where that is in the unit circle. Okay. So let's see. In the unit circle, we know that this is 0 here, and this is pi over 4. And this 9 pi over 4 is some multiple of just pi over 4. So let's see if we can figure it out. So this is pi over 4 and another pi over 4. I'm going to count by pi over 4s. Gets us up to pi over 2. That's like a 45-degree angle and then up to a 90-degree angle. Then we can go another 45 degrees here, and that gets us, by adding another pi over 4 on, that gets us to 3 pi over 4. And then continuing up to here, this gets us to 4 pi over 4, which is just the same as pi. So that's like 180 degrees is pi. Now we're not there yet. We're looking for 9 pi over 4. That's what we're trying to find here. So we keep going. 4 pi over 4. This one down here is going to be 5 pi over 4. This one is going to be 6 pi over 4, or we can cancel and make that 3 pi over 2. Oopsie. This one down here is, let me see, 6 pi over, this one is 7 pi over 4. And then this one is 8 pi over 4, because 8 pi over 4 is just 2 pi, and that's like once around the circle. And then 9 pi over 4 is as though we've gone all the way around. Here's 1 pi, 2 pi, 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4, 8 pi over 4, and another pi over 4 gets us up to 9 pi over 4 is right here. So this is just equal, 9 pi over 4 is just equal to pi over 4. They're the same angle, yeah? Just that one of them, it only goes up this far, 1/8 of a turn, and one of them goes all the way around and then a little bit farther. They point the same direction, rather. Are they the same angle? It's a great philosophical question. Okay, so pi over 4, this 9 pi over 4, this is equal to pi over 4. That's handy, and that's handy because this is one that we know. This is the one, 45 degrees, that's where sine and cosine are equal to each other, and they're both equal to radical 2 over 2. Okay. So cosine of 9 pi over 8, the steps are split up 9 pi over 8 into 9 pi over 4 over 2. This is by using, we're going to be using a half angle identity, something over 2. And 9 pi over 4, figure out where on the unit circle it is. It happens that 9 pi over 4 is just exactly equal to pi over 4. So we can go ahead and use this fact here. Cosine 9 pi over 8, this is equal to, well, I'm just rewriting that 9 pi over 8. This is cosine of 9 pi over 4 over 2. This is splitting it up as a half. And to rewrite this, we just need to know what is the formula, the half-angle formula for cosine. We'll go ahead and look that one up. Here it is. For cosine, it's the second one there. Okay, we'll leave that right there as a reference. This one is equal to, plus or minus radical Whoops. Didn't want it to do that. Oop. Hey, things going crazy. Okay, interesting. All right, we're going to try again. Here we go. Plus or minus radical 1 plus cosine of 9 pi over 4, whole thing over 2. That's a 1 there, because that's difficult to read. Okay, and we need to know what is cosine of 9 pi over 4. Well, we saw here 9 pi over 4 is the same as pi over 4. And the cosine of that is the same as the sine, which is radical 2 over 2. The 45-degree angle, pi over 4, has the same sine and cosine, radical 2 over 2. And that pi over 4 is the same as 9 pi over 4. So where does that leave us? Well, this whole thing is then equal to plus or minus radical 1 plus, and this is radical 2 over 2, and then whole thing over 2. Okay. Once again, we have a little bit of a fraction to untangle here. There's various ways to do this. One of them, the way that I did it last time, was I took this 2, flipped it over and brought it up above and multiplied it through. That's a fine way to do it, and it will work just as well here. I'm going to do this one using a different algebra strategy, just because some people like this one better. I'm going to take this entire fraction, the big fraction, and multiply top and bottom by something that will get rid of the denominator on that little fraction on the top. And in particular, I'm going to multiply by 2 on the top and the bottom. It turns out that doing it this way actually saves us a step. We'll see how that works. So this one is equal to plus or minus radical. On the top, multiplying the 2 through, 2 times 1 is 2, and 2 times radical 2 over 2, it cancels the 2 and just leaves a radical 2. On the bottom, 2 times 2 is 4. Okay. Now we have a same idea, which is we can, since this is the radical of a fraction, we can split it up as the radical of the top, 2 plus radical 2, over the radical of the bottom, radical 4. And that altogether is plus or minus radical 2 plus radical 2 over 2. Okay. We're almost there. What we've found so far is cosine of 9 pi over 8 is equal to this. Let me just put a little divider through here. This is almost our answer. The only trouble is this plus or minus. We have to decide whether the cosine is positive or negative. And to do that, we need to figure out where is this angle, 9 pi over 8. Where on the unit circle is it? And be careful, the analysis we did before, finding this angle here, this was the angle 9 pi over 4, but we are interested in the angle 9 pi over 8. So how do we do that? Well, I'm going to do it as follows. 9 pi over 8, just think about the fraction 9 over 8. 9 over 8 is a little bit more than 1. Yeah, it's, if we think of this as just 8 pi over 8, that would be the same as pi, and 9 pi over 8 is a little bit bigger than that. Now, the angle pi is the one that's 180 degrees. It's over here. Yeah, and so if this is pi, pi is like 8 pi over 8, and we add another pi over 8 gets us down here. It's going to be in quadrant 3. So this guy is in quadrant 3. Now, in quadrant 3, remember down here when you're looking at the terminal angles of terminal sides of angles, x is like cosine and y is like sine, and in the third quadrant, the x is negative and the y is negative. That means both cosine and sine are negative. So this cosine is going to be negative. There we go. Whoops. So final answer, cosine 9 pi over 8 is equal to negative radical 2 plus radical 2, whole thing over 2. And that's our final answer. And just so that it's written down here, Q3 cosine is negative. Okay, that's our solution for part B. And take a look, think it through, go back and try the problem yourself, see if you can do it, and we'll go ahead and do part C now. Okay, looking at part C is tangent of pi over 24. So let's see if we can figure this one out. So this is C, tangent of pi over 24 equals. Okay. So first we rewrite that angle pi over 24 as a fraction over 2. So we notice that pi over 24 is equal to pi over 12 over 2. So that's a good start, and it says that we can write this in the same way, tangent of pi over 12 over 2. Now, the formula for tangent of a half angle, well, we'll go up and grab that. So it looks like it's a big, long, horrible mess, but what it's really giving you is 3 different formulas for the tangent of an angle over 2. And it's up to you to choose which is the formula that's going to make your life easier. It may seem annoying to have 3 formulas, but in fact, the point is to try to make our lives simpler. So we can either choose this one or this one or this one. This one uses cosine and sine. This one uses sine and cosine. This one just uses cosine of the original angle alpha. Now, what is the original angle alpha? Here, alpha is pi over 12. Do we know sine of pi over 12 or cosine of pi over 12? If you look back, if you were with me on the previous video, you would know that we calculated the cosine of pi over 12. That was the very first angle summation formula that we did. So just as a recall, cosine of pi over 12, that one is equal to radical 2 plus radical 6 over 4. Now, we didn't ever calculate sine of pi over 12. We could, using the Pythagorean theorem, the trig identity sine squared plus cosine squared equals 1. But I don't think that we need to, and the reason is that this is the cosine, and one of the formulas for tangent of alpha over 2 involves only the cosine right here. See, it has 1 minus cosine and 1 plus cosine. So let's just go ahead and use this formula right here. What we're going to do is I'm going to rewrite this tangent of pi over 12 over 2. This is my angle alpha, pi over 12, and I'm going to use this formula, substituting in pi over 12 for my alpha. Okay, so the whole thing is plus or minus, copying carefully and leaving myself a lot of room because this is going to be big and somewhat messy. We have 1 minus cosine pi over 12 over 1 plus cosine pi over 12. Great. So let's see. We still have a plus or minus, and we know what cosine pi over 12 is. It's this somewhat messy thing right here. So let's go ahead and substitute that in. Plus or minus radical 1 minus radical 2 plus radical 6 over 4 over 1 plus radical 2 plus radical 6 over 4. My goodness. I'm going to just make this radical a little bit taller to show that it really covers this entire big fraction with the several fractions buried inside it. Okay, So look, this is the answer, except that it's not simplified. And, well, there's two things. It's not simplified, and we haven't decided whether it's positive or negative. So those are the two things, basically, that we have to figure out. To simplify it, when I look at this, I see a radical. Let's leave that big outer radical alone. Inside, there's a big fraction, and on top of the big fraction, there's a little fraction, and on the bottom of the little fraction of the big fraction, there's another little fraction. What I'm going to do is simplify this by taking the big fraction and multiplying through the top and bottom of it by something that will cancel off these little denominators. Namely, I will multiply through by 4. So if I multiply the big fraction by 4 over 4, now I'm going to take this 4 and multiply by each of the two pieces here, and take this 4 and multiply by each of the two pieces here, and that should simplify this thing a lot, maybe not all the way. We're going to see how it looks. So, whoops. Here we go. This one is plus or minus, and it is radical. When I multiply 4 times 1, I get 4. And when I multiply 4 times that fraction, it just cancels the 4 with the 4 in the denominator, so it's minus radical 2 plus radical 6. Now, easy place to make a mistake is to forget that the top of that little fraction, this guy right here, it's really in parentheses, and that minus is applied to the entire fraction, which means we can't lose track of that even though we cancel out the denominator. That minus still had better be applied to everything in there, and that's why I put that in parentheses. I'm going to do the same thing on the bottom. 4 times 1 is 4, and then plus, and then parentheses radical 2 plus radical 6. I'm going to put those parentheses in just to emphasize that those things are still kind of grouped together, although it doesn't make any difference on the bottom because what's in front of the parentheses is a plus, and that distributes through without changing anything. So we could just get rid of the parentheses if we wanted to. Okay, so one more simplification step. This is plus or minus radical 4 plus 4 minus radical 2 plus radical 6 over 4 plus radical 2 plus radical 6. Okay, we're doing pretty well. We've come a long way, but when I see that my radical is maybe still not going down far enough, I'm going to make that just a little clearer by going like that. There we go. But when we managed to simplify the inside so that there's no longer these little fractions inside. It's just one big fraction. That's a good start. But this big fraction has this irritating problem, which is that it has radicals on both the top and on the bottom. So let's see. Okay, what we'd like to do is we'd like to get rid of these radicals down here. And in order to do that, we're going to, the usual idea would be to take this and multiply by the conjugate. But there's, of course, 3 terms down here, and so it's not totally clear how to multiply by the conjugate. Can it be done? Yes, there is a trick, which is grouping 2 of the terms together. However, I am not going to do it here. I think that this simplification is going to end up taking a bit more time than I want to spend right now. I will give you a final answer, and I will leave it under the category magic of where this answer came from. Okay, so if we simplify this, it's plus or minus, and what does it all come out to in the end? Well, it comes out to the following: radical 6 plus radical 2 minus radical 3 minus 2. And where the heck did we get all of that from? Really good question. That's the magic. Okay. The short view, the peek into what the magic is that we have to take the denominator, group two of the items together so that we have a single, these sort of considered as one, and then you have one item plus another, and we can multiply by the conjugate. That'll take care of one of the radicals, and then we do the same thing, grouping the non-radicals together, multiply by the conjugate, and the thing will work itself out. Okay, we're not going to go through that now. Here's what we're going to do instead. We're going to worry about this. Should it be positive or negative? Should the final answer end up being positive or negative? Well, let's take a look and see. So the way that we determine whether it's positive or negative is by checking out the quadrant of this angle. And the angle that we're interested in, remember back at the beginning of this problem, it was tangent of pi over 24. Pi over 24, I mean, the 1 over 24, that fraction is a pretty small number. So if this is 0, and this is pi over 2, and this in the middle is pi over 4, and this is pi over 6, then pi over 24 is going to be something like this, pi over 24. And that is in the first quadrant. So this is quadrant 1. In quadrant 1, cosine and sine are both positive because x and y are both positive. And so tangent, which is sine over cosine, is also going to be positive because a positive over a positive is a positive. So quadrant 1, tangent is positive. And so we choose the positive of these. So this is equal to positive radical 6 plus radical 2 minus radical 3 minus 2. And that is our final answer for the tangent of pi over 24. Okay, that's it for this one. I hope you followed along. Please let me know if not, if you have questions. And we'll dive into our last example, which involves using the double angle formulas in the next example, in the next video. Thanks.